नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार, फैकल्टी ऑफ मेजरमेंट्स में आप सब लोग को स्वागत कर रहा हूं। जल्दी से जल्दी ज्वाइन करो बेटा। जितने लोग लाइव में हैं मुझे एक बार एबीसी कंफर्मेशन कर दीजिए, ऑडियो वीडियो क्लियर या नहीं। यहां से हम फटाफट डिस्कस करेंगे। आज का टॉपिक एनर्जी मीटर है, बट इसके पहले हम लास्ट क्लास में हमने जो जो डिस्कस किया उसके बारे में डिस्कस करके देन वी विल गो फॉर दिस टॉपिक्स आर एक्सक्लूसिवली फॉर इलेक्ट्रिकल पीपल एंड इंस्ट्रूमेंटेशन पीपल। बेटा हाउ मेनी ऑफ इलेक्ट्रिकल स्टूडेंट्स आर देयर? एक बार मुझे थम्स अप दिखाइए। एंड इंस्ट्रूमेंटेशन पीपल को भी ये सेशंस बहुत यूजफुल है। सो लास्ट क्लास में हमने रिकैप ऑफ प्रीवियस लेक्चर्स देखा तो हमने क्या डिस्कस किया। 3 फेज पावर मेजरमेंट स्टार्ट किया था। सो डायनामोमीटर, वाट मीटर वी हैव डिस्कस किया था। सो वी हैव डिस्कस द डायनामोमीटर। डिफ्लेक्शन टॉर्क इज इक्वल टू I square dm by d theta. Controlling torque is equal to kc theta we have discussed. Next we have taken the dynamometer, watt meter, and we have discussed the power expression VPC ICC cos phi. Then we have discussed the LC connection and MC कनेक्शन। जितने लोग लाइव में हैं एक बार प्रीवियस लेक्चर्स कलेक्ट करके देखो यार, ये बहुत इंपॉर्टेंट टॉपिक है, एलसी कनेक्शन एंड एमसी कनेक्शन। ओके, सो आज का क्लास में हम 3 फेज पावर मेजरमेंट डिस्कस करके देन सडनली विल गो फॉर द एनर्जी मीटर। ओके, गुड मॉर्निंग टू ऑल। गुड मॉर्निंग टू वन एंड ऑल। संतोष गुड मॉर्निंग। वरपुला संतोष गुड मॉर्निंग। या चलो आज का क्लास में हम डिस्कस करेंगे 3 फेज पावर मेजरमेंट, टू वाट मीटर, इसके बाद हम डिस्कस करेंगे एनर्जी मीटर, नेक्स्ट इसके बाद हम डिस्कस करेंगे गेट PYQs। ओके, रेडी है? चलो 3 फेज पावर मेजरमेंट के बारे में पहले डिस्कस करेंगे। क्या होता है 3 फेज पावर मेजरमेंट? देखो, एक्चुअली सिंगल फेज सप्लाई विल बी सुटेबल फॉर द डोमेस्टिक एप्लीकेशंस, but 3 फेज supply suitable for industrial applications. 3 फेज supply suitable for mostly industrial applications. Power companies, ratings, okay, production companies, इसमें हम 3 फेज supply के यूज करना पड़ता है। So 3 फेज supply is having same frequency, same magnitude, but they will have a phase shift of 120 degrees. If you see this 3 फेज supply, they will be having a phase shift of 120 degrees. So this is a VRN, this is a VYN, this is a VBN. So you can take this as IRN, IYN, IBN. This is IRN, this is IYN, this is IBN. This angle is phi, this angle is so phase voltage, phase current. Excuse me. This is also phase current. So please note down the advantage of the 3 phase. So if you see the advantages are more voltage. Three-phase supply can generate the more voltages, and it is having the transmission of three-phase power. Transmission of three-phase power requires less copper wire, connection less connections and economical. इंडस्ट्री में थ्री फेस पावर को जनरेट करने के लिए अगर आपने सिंगल फेस पावर से किया था, सिंगल फेस पावर में क्या होना चाहिए आपका करंट कॉइल कनेक्शन चाहिए, आपको प्रेशर कॉइल कनेक्शन चाहिए. अगर ये दोनों कॉइल्स मिलते तो एक फेस हो जाएगा, इसके साथ लोड भी होगा. अगर थ्री फेस के लिए कितना कॉइल्स होना पड़ता है? 6 कॉइल्स होना पड़ता है. 3 सिंगल फेस से कनेक्शन, सिंगल फेस से आप कनेक्ट करते जाए. सो इफ यू यूज 3 सिंगल फेस, 1 सिंगल फेस रिक्वायर्स 2 ना, so 3 single phase requires 6. So that's how it happens. Okay, so next, RMF is the rotational magnetic field. So 3 phase supplies for the RMF means हमारा induction machines में, squirrel machines में, synchronous machines में भी आपको motors में rotational magnetic field is necessary ना to create rotation in the particular equipment. Okay, so for all these purposes. चलो, so if you see this, now from this what I can take, one three phase supply is equal to 2 3 single phase supplies, but vice versa may not be true. मेरे दोस्तों, but vice versa may not be true. Three phase supply, 3 single phase supplies, but vice versa may not be true. Chalo. Now if you see three phase supply, in three phase supply we have these models, star model and delta model. So this is a symbol of star model and this is a delta model. Okay, so this is a star model of C. If you see the sequence of RYB sequence, and this is also delta model, RYB delta model. अगर आपको नेटवर्क थ्योरी पसंद है तो नेटवर्क थ्योरी में आपको ये इसके बारे में बहुत सारा कंटेंट मिलेगा. सो दिस इज RR डैश, दिस इज YY डैश, दिस इज BB डैश. ओके, सो आप इसको न्यूट्रल लाइन ले सकते हैं, ओके. चलो, दिस इज ऑल्सो डेल्टा कनेक्शन, RR डैश, YY डैश, ओके, BB डैश. सो दिस आर R फेस, दिस आर Y फेस, दिस आर B फेस, R5 B फेस, R फेस, Y फेस, B फेस. ओके, अगर नाउ थ्री फेस पावर सप्लाई में अगर आपने कुछ पॉइंट्स लिए तो the conclusions from the star model and conclusions from the delta model. So if you see the conclusions for the star model and conclusions for the delta model, so what are the conclusions? I can take it. So first of all, line current is equal to phase current. Line current is equal to phase current. Here line current is √3 times of phase currents. So here line voltage is √3 times of phase voltages. Here line voltage is phase voltages. Okay, here line voltage leads, here line current lags. Okay, समझ में आपको? चलो, so now let us go for the 3 phase supply with a 4 wire system. 4 wire system means I am taking R, Y, B plus a neutral line. Okay, so this is a R phase, this is a Y phase, this is a B phase, and there is a separate neutral line is also present. So R, Y, B and separate neutral line. So this is what we call as current coil. So this is a current coil, and for that we are connected a pressure coil, and this is a current coil, for this is connected pressure coil, this is a current coil, for this connected pressure coil. So this is wattmeter 1, this is wattmeter 2, this is wattmeter 3, and these 3 wattmeters are connected to a separate neutral line. These wattmeters are connected to separate neutral line. So now this will be Rn, this will be Bn, this will be Yn. So अगर आपके पास सेपरेट न्यूट्रल लाइन है, जिन जरूर आपको 3 वाटमीटर्स का जरूर पड़ता है. ओके, एक R विथ कनेक्टेड टू न्यूट्रल, Y कनेक्टेड विथ न्यूट्रल, B कनेक्टेड विथ न्यूट्रल. सो Rn, Yn, Bn. ओके, VRN, VYN, VBN. So this is a wattmeter 1, this is a wattmeter 2, this is a wattmeter 3. So every watt power connection requires one current coil, one pressure coil. So wattmeter 1 का reading क्या होगा? If you see the wattmeter 1 reading, so that will be connected between R to N. So that is VRN into IR, cosine angle between VRN and IR. Suppose if you take the wattmeter 2, wattmeter 2 is connected between IB and this. So VBN, IBN, cosine angle VBN and IBN. Okay. Next, wattmeter 3, if you see the pressure coil is connected between Y and this N. So VYN, I, it is going for a IYN, cosine angle VYN and IYN. Okay. Santosh, are you there? So now this is the concept, VRN IR cos phi. So यहाँ से आपको क्या मिलेगा? VRN बोले तो VPH, IRN बोले तो IPH cos phi. So this is also VPH, IPH cos phi. So total 3 phase voltages आ गए आपको. So 3 phase power का expression क्या हो गया मिला के? W1 plus W2 plus W3 हो गया. So VRN is equal to VYN is equal to V by N is equal to VPH हो गया. Okay, so VRY is equal to VYB is equal to VBR is equal to VL हो गया, and IRN, IYN, IBN is equal to IPH हो गया, IR is equal to IY is equal to IB is equal to IL हो गया. So this is the phase voltage. This is the phase voltage, and this is the line voltage. This is the phase current. This is the line current. ओके, नोट करो बेटा. Noted. This is with the RYB sequence with separate neutral line. Now इसके साथ साथ अगर आपको 2 wattmeter से कैसे कर सकते हैं? There is a one famous theorem called Blondel's theorem. According to Blondel's theorem, अगर आपके पास separate neutral line है, then आपको 3 wattmeters का जरूर होता है. अगर separate neutral line नहीं है, then आपको n-1 wattmeters use कर सकता है. That's what the Blondel's theorem. So what was the Blondel's theorem is telling? For an in-phase balanced system, if a separate neutral line is not present, then n-1 wattmeters are required. For an in-phase balanced system, if a separate neutral line is present, then n number of wattmeters are required. N number of wattmeters are required. If a separate neutral line is present, आपको n number of wattmeters चाहिए. If separate neutral line is not present, then n-1 wattmeters are required. Okay. So if you see the balanced system, the magnitude of voltage remains same. The frequency of the voltage remains same, the magnitude of impedance remains the same, the phase of the impedance remains same, the type of the impedance also remains the same. The type of the impedance also remains the same. Okay. So now if you see the 3-phase balanced star model lagging power factor, so this is the 3-phase balanced star model, lagging power factor. So if you see the three phase, how the three phase will work. Okay, so this is the coil, this is the foil, this is another coil. So now if you take this, now I am taking one of the particular line as common. So the B line I am taking as common. So from this is connected here and this is connected to here. So these two are connected here and these two are connected here. So now this particular will be the line to line voltage. So this is R to B, so VR to B, and this is from Y to B, so this is V Y to B ho gaya. Okay, so now if you see the W1, what is the W1? The W1 will be V R2 B into IR cosine angle VRB to IR. Next, W2 will be what? W2 will be connected from Y to B. So V Y to B, and this is IY cosine V Y to B and IY. Okay, so this is the wattmeter readings. So let us find out the VRB IR angle. So this is the concept, VRB IR cosine, VYB cosine. So what is a VRB? VRB, I can take it as VRN minus VBN. So VRN minus VBN means if I take the plus out, you can take like this vectors. VYN minus VBN means you can take like this, like a vector addition. So now if I am taking the angles, so how to draw the angle? See here. This is my VRN, this is my VYN, this is my VBN. So this particular angle is 120 degrees. This particular angle is 120 degrees. So this VBN and for every phase voltage there is a phase current. The phase current will be having a phase angle of phi. So VRN and IRN having a phase shift of phi, VYN and I1 having a phase shift of phi, VBN and IBN are having a phase shift of phi. Okay, agar if you take this as a VBN, the opposite will be minus VBN. Now the resultant of this VRN and minus VBN is the VRB. The resultant of this VRN and minus VBN is the VRB. So now this particular thing is the line voltage VRB. So the voltage, this is the VRB, and I want the angle between VRB and IR. So this particular angle we check. So this total was 120, right? This total was 120. If you split it, it will be 60 60. Again if you split it, this is 30. So this angle is 30 minus 5 hoga. So that is what I want to tell you, 30 minus 5. Similarly VYB and IY ke beech mein dekha to, so VYB I want, so VYB is this, VYB कैसा आएगा? So this is VBN, इसका नेगेटिव वेक्टर माइनस VBN, इसका रिजल्टेंट VYB होगा, एंड VYB एंड IY के बीच में एंगल कितना होगा? 30 + 5 होगा. ओके, जिंदा हो, जीवन में हो, अगर कोई लाइव में है तो मुझे बताओ यार. सो दिस फेजर अंडरस्टैंडिंग इज वेरी वेरी इंपॉर्टेंट. अगर आपको फेजर अंडरस्टैंडिंग, 8 स्टूडेंट्स आर वाचिंग द लाइव, सो एक बार रिस्पॉन्ड दीजिए. जितने लोग लाइव में देख रहे हैं मुझे रिस्पॉन्ड दीजिए. W1 रीडिंग W2 रीडिंग, सो यहां से W1 W2 रीडिंग क्या आएगा देखो, सो W1 रीडिंग ये है VRB IY cos of 30 minus 5, so this will be VL IL cos of 30 minus 5. W2 reading VYB IY cos of 30 plus 5. So this is a W1 and W2. So if you take, this is a W1 and this is the W2. Okay. So W1 will be 30 minus 5, W2 is 30 plus 5. You take W1 minus W2. So this minus this VL IL cos of 30 minus 5 minus VL IL cos of 30 plus 5. So if you take VL IL out, cos of 30 minus 5 minus cos of 30 plus 5. So this you can write as cos A cos B plus sin A sin B minus cos A cos B, cos of A plus B, cos A cos B minus, so plus sin A sin B. Okay, so this is cos A cos B plus sin A sin B minus cos A cos B plus sin A sin B. So now this cos 30 cos 5 gets cancelled and this will become as 2 sin 30 sin 5. So the sin 30 is equal 1 by 2, 2 gets cancelled, VL IL sin 5 आ गया. So this is W1 minus W2 हो गया. W1 minus W2 मुझे मिला है, VL IL sin 5 मिला है. So similarly I will go for W1 plus W2. So if you go for W1 plus W2, VL IL cos of 30 minus 5 plus VL IL this. So if you take VL IL common, so what I am going to get, if I take VL IL common, so cos of 30 minus 5 plus cos of 30 plus 5. So again if you see this, this is cos A cos B plus sin A sin B plus cos A cos B minus sin A sin B. So sin A sin B gets cancelled, you will get 2 cos A cos B. So this is the cos 30 cos 5 and this is a cos 30 cos 5 and this terms gets cancelled. Okay, so आपको क्या आ रहा है, 2 cos 30 cos 5. Cos 30 is equal to root 3 by 2, 2 gets cancelled. So I am going to get VL IL root 3 by 2. So here root 2 था, so this 2 gets cancelled. Okay, so root 3 VL IL cos 5. So 4 equations मुझे आ रहा है. फर्स्ट इक्वेशन ये है, W1 का इक्वेशन ये है VL IL cos of 30 minus 5. W2 की इक्वेशन क्या है, VL IL cos of 30 plus 5. W1 minus W2 का फॉर्मूला VL IL sin 5. W1 plus W2 का फॉर्मूला root 3 VL IL cos 5. सो अगर आपने दोनों का रेशियो लिया है, W1 minus W2 by W1 plus W2 का रेशियो लिया, देन क्या होगा, आपका आंसर VL IL sin 5 root 3 VL IL cos 5. So that will become 1 by root 3 tan 5 होगा. So tan 5 is equal to root 3. So this is the expression. So tan 5 is equal to root 3 W1 minus W2 होगा. So यहाँ से आप 5 कैलकुलेट कर सकते हैं. 5 is equal to tan inverse of root 3 W1 minus W2 the whole divided by W1 plus W2 होगा. So यहाँ से आपने पावर फैक्टर को निकाल सकते हैं. पावर फैक्टर इज इक्वल टू cos 5. सो प्लीज नोट डाउन दिस पर्टिकुलर 4 फॉर्मूलास. अगर ये 4 फॉर्मूलास याद है तो आप एग्जाम में कोई भी फॉर्मूला कर सकते हैं, कोई भी क्वेश्चन कर सकते हैं. कर लो बेटा फटाफट. एनीबॉडी इज हैविंग एनी डाउट्स, लेट मी नो. नोट करो बेटा, tan 5 का एक्सप्रेशन नोट कर दिया. tan 5 का एक्सप्रेशन नोट करो. So based on this, now I can go for some analysis of the power factor. So first of all, by using 3 watt meters, by using 2 watt meters के बीच में differentiation क्या है, ध्यान से देखो. So if you see the differentiation in 3 watt meter method, that means 4 wire. 4 wire means what? हमारे पास R, Y, B इसके साथ साथ N है. R, Y, B साथ साथ N है. So W1 is equal to VPH IPH cos phi, W2 is equal to VPH IPH cos phi, W3 is equal to VPH IPH cos phi. So summation will be 3. So 3 phase 3 watt meter में 3 watt meters का 3 phase power में 3 watt meters are required for you. Okay, so 3 VPH IPH cos phi हो गया. But now 2 watt meter method, if you see in 2 watt meter method we are using the 3 wire. So 2 watt meter means W1 plus W2. So with W1 plus W2 we are getting 2 watt meter में हमको क्या आ गया expression W1 plus W2 आ गया. So root 3 VLIL cos phi. So for star model, so what we can write for star, VL is equal to root 3 VPH लिख सकते हैं. So if you write that root 3 VPH here, so that will become as 3 VPH IPH cos phi. Okay, so root 3 VPH IPH cos phi. So W1 plus W2 हो गया. So आपको 3 watt meters में जो आ रहा था, so that you are able to get with 2 watt meters. आपको what actually you are getting with 3 watt meters, that you are getting with 2 watt meters. चलो next if we go for reactive power also possible है. आपको everybody knows that 3 phase active power, real power, that is 3 VPH IPH cos phi. 3 phase reactive power, that is 3 VPH IPH sin phi. 3 phase apparent power, that is 3 VPH IPH. So this is kilovolt ampere reactive. Am I right? So this is what? Kilovolt ampere. So kVAR, kilovolt ampere reactive. So this is kilovolt. So this is a reactive power, this is a active power, this is a real power. आपको पता है. So उसके बीच में relation क्या है? S is equal to, this is S, this is Q, this is P, square root of P square plus Q square. So by 2 watt meter method, if you see that W1 plus W2, ये active power मिल गया आपको. W1 plus W2 लिए तो हमको active power मिल गया. W1 minus W2 से क्या मिल गया? W1 minus W2 को हमको VL IL sin phi मिल गया. W1 plus W2 को active power मिल गया. W1 minus W2 से क्या मिल रहा है हमको? VL IL sin phi मिल रहा है. Yes or not? So if you multiply both with root 3, so VL is equal to root 3 VPH now. So you can write like this one more statement. VL is equal to what? So what was the VL? VL is equal to root 3 VPH, IL is equal to IPH sin phi. Okay. So now if I multiply with both terms with root 3, so root 3 gets cancelled. Root 3 VPH IPH sin phi आ रहा है. So which is nothing but a reactive power. इसका मतलब क्या है? आपको 2 watt meter से कितना बेनिफिट्स हो रहा है? 3 watt meters में 3 watt meters यूज करना पड़ता है, लेकिन यहाँ आपने 2 watt meters यूज कर रहे हैं, 1 watt meter लेस हो गया. दैट इज वन बेनिफिट. आपको 3 फेस पावर मेजरमेंट करने के लिए W1 प्लस W2 प्लस W23 किया 3 वाट मीटर्स का जरूर पड़ना था. इधर केवल 2 वाट मीटर्स से W1 प्लस W2 से आपको 3 फेस पावर मेजरमेंट का प्रोसेस कंफर्म हो गया. यू आर गेटिंग द 3 फेस पावर विद 2 वाट मीटर्स. इन बोनस में क्या आ रहा है? अगर इसका समेशन के बाद आप सब्ट्रैक्शन लिया रूट 3 टाइम्स, यू आर गोइंग टू गेट द रिएक्टिव पावर आल्सो. ओके, सो W1 plus W2 is giving me 3 VPH IPH cos phi, and W1 minus W2 into root 3 is giving me 3 VPH IPH sin phi. Okay, so this is what they are getting. Understood? So please make a note of this point. Please note down. Done. Chalo. Now based on this, now we'll go for a question. Before going for a question, let me take some confirmation. So some equations. So W1 का equation ये है, VL IL cos of 30 minus 5 है. W2 का equation ये है, VL IL cos of 30 plus 5 है. अगर ये दोनों में से हमको क्या आ रहा है, tan phi आ रहा है, that is root 3 W1 minus W2, W1 plus W2. So now if you see this phi, so from this power factor is coming, that is a cos phi. Power factor is coming, the cos phi. So W1 and W2 both are same. I am taking now. So if I am taking phi is equal to 0, cos phi, power factor will be unity. Let us see the readings of W1, W2 and what can be happen. So let us see the readings of W1, W2 and what can be happen. So W1, W2 if you see here, so this is unity power factor. W1 if I take 30 minus 0, so root 3 by 2 VL by IL, this 30 plus 5, root 3 by 2 VL IL. So the total will be W1 is equal to W2. So next, if you take the 30, phi is equal to 30, 30 minus 30, 0, cos 0, 1, power factor 0.86 is here. So please substitute this 30 if we substitute here, 30 minus 30, 0, cos 0. So this is VLIL. So 30 plus 30 VLIL2. That means second wattmeter reading is the half of the first. So if you see the second wattmeter reading will be the half of the first. So second wattmeter reading will be half of the first one. Next, if you take the 60 degrees, 30 minus 60 minus 30, that is 30 minus 60 minus 30 cos 30, that is root 3 by 2. Here 30 plus 60, 30 plus 60, 90 cos 90, 0. So one of the wattmeter reading is equal to 0. समझ में ना आपको? Yeah. Next 90 if you take, power factor will be cos 90, 0, and this will be 30 minus 90 minus 60, that is cos 60 VLIL2. This is 30 plus 90 cos 120. Cos 120 means minus sin 30, that is minus VLIL2. That means one of the wattmeter reading is negative. So here W2 is equal to minus of W1. Okay, and here W2 is equal to 0. So how to analysis this? अगर आपने ये 0.5 को reference लीजिए, power factor 0.5 को. If you take this power factor 0.5 reference, this above 0.5, this above 0.5, and this is below 0.5. This is above 0.5 and this is below 0.5. So above 0.5 all are positive. I will see these all are positive. So below 0.5 they are negative. So that's how it works. Okay, chalo. Now let us go for the questions. So I have taken the reference. This is if power factor is equal to 0.5, one of the wattmeter ring is equal to 0, and above power factor 0.5 there are positive readings, and at less than power factor the readings are negative, and power factor is equal to 1, unity. Okay, so this particular relation आपको यूजफुल होगा. जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए, मैं फटाफट प्रॉब्लम्स के पास जा रहा हूं. आंसर कर दी इस क्वेश्चन. आईआईटी मद्रास 91 का सवाल है, जल्दी आंसर कर लो भाई. Option A, W1 is equal to W2. So what is this? Two identical wattmeters are connected to measure power. Connected, the load power factor is dash. अरे यार W1 W2 dash, the load power factor is dash when two cases, when W1 W is equal to 2, what is the cos phi is asking, and one of the wattmeter it is equal to 0, what is the cos phi is asking. So just before I told you, for unity power factor only you are getting, so cos phi is equal to 1 here, and any one of the wattmeter reading is equal to 0 means cos phi is equal to 60, cos phi is equal to 0.5 here. So that's what you have to understand. This is 1 and this is 0.5. One of the 0.5, one of the meter reading is equal to 0. Okay बा, चलो let us go for one more question. IIT Bombay 2005 का सवाल है, जल्दी आंसर कर लो बेटा ये क्वेश्चन को. Try to answer this particular question. Make it fast. Saikat Malik. Two wattmeters which are connected to measure the total power in a three-phase system have a balanced load. So W1 is given as 10.5 kilowatts and W2 is given as minus 2.5 kilowatts. Okay, so the total power and the power factor respectively, the total power they are asking, total power means W1 plus W2 hoga. So that is 10.5 minus 2.5 kilowatts hoga. So why? Because actually a 10.5 plus minus 2.5 hoga, so that becomes as 8 kilowatts hoga. Next W1 minus, so what is asking? The total power and the power factor is asking. So आपने tan phi use कर सकते हैं formula. So tan phi is equal to √3 into W1 minus W2 the whole divided by W1 plus W2. So √3, W1 is equal to 10.5 minus of 2.5 the whole divided by 10.5 plus of W2 minus 2.5. So tan phi, what is the answer you are going to get? So for tan phi we are going to get as √3. So this is 10.5 plus 2.5 divided by 10.5 minus 2.5. So simplify करके बताओ यार कितना आ रहा है. So 10.5 plus 2.5 divided by 10.5 minus 2.5. So shift tan inverse of answer 58, cos of answer 0.524. So cos phi from this question I am going to get as 0.524. So the right answers are these are W1 plus W2. Understood? So these are W1 plus W2 and this 0.524. Option C is the right answer beta. Chalo, let us go for the next question. Yeah, answer this question. IISc Bombay 99 का सवाल है. The voltage phasor of a circuit is 10 with 15 degrees and the current phasor is 2 minus 45. Okay, the active and the reactive powers in the circuit are dash. आंसर कितना होगा इसका? So if you see this question, you have to take some reference. Take a reference. Okay, so let us take this a VRN, something like that. Okay, some reference you take. V reference you take something. Okay, and voltage phasor of a circuit. So with reference it is making 10. So this is a VPH, that is making as 10 15 degrees volts. Okay, so this particular angle, I'm taking as 15 degrees. Next, current phasor I'm taking like this is a current phasor. So this is a current phasor IPH, so that is making as 45 degrees. Okay, so now ये दोनों के बीच में क्या है, IPH कितना है, 2 है. So VPH IPH के बीच में, VPC IPH के बीच में कितना एंगल, so this is the IPC, so this is the ICC we can take, this is the VPC we can take. Okay, so he's asking the active power. एक्टिव पावर का फॉर्मूला क्या है, VPC ICC cos phi. So VPC is how much, 10, ICC how much, 2, cos phi, that is cos of 15 minus 45, that is 60 degrees. So 20 into 1 by 2, so 5 watts. ऑप्शन दिस होगा. रिएक्टिव पावर पूछ रहे, so Q रिएक्टिव पावर, that is VPC ICC sin phi. Okay, that is 10 to sin 60, so 10 root 3 हो रहा है. Active power VI cos phi, yeah, this is wrong. 20 into 1 by 2, 10 watts. This is 10 into 10 root 3, 1.7, 17.32. Okay, so the right answers are option गलत है ये. So this is the right answer. Okay, chalo, let us go for the next question. So now we'll go for the energy meter. So please make a note of energy meter diagram first. So this energy meter diagram, after the energy meter diagram, we'll go for it. consumed. So if you see, energy meter का basic purpose है energy consumed. So energy is derived as power into time. Energy meter can be taken as integrating instrument. Energy meter is taken as an integrating instrument because it goes on integrating the readings. It goes on accumulating the readings. It goes on accumulating the readings. So energy is equal to power into time. So energy का unit है 1 unit. 1 unit is equal to 1 kilowatt hour. So actually energy का units क्या होता है? Power into time होता है. Power बोलो तो VI cos phi into time. So VI cos phi into time. So this is kilowatt and this time is hour. So this is the energy unit. Okay, chalo. So 1 unit is equal to 1 kilowatt hour. So what is going to happen? The watt hour meters is going to be the energy meter का एक नाम भी है watt hour meter. हमारे घर में energy को consumption को measurement करने के लिए ये unit use कर सकते हैं. चलो, let us go for the next. So directly I am taking some questions here. The speed of revolution, actually in energy meter क्या होता है ना? The number of revolutions generally in energy meter जो भी number of revolutions है, so that will be proportional to the energy consumed. So if we remove the proportionality, I am going to get one constant, that is what we call as energy meter constant. So K is equal to N by E. So this is revolutions, energy meter is kilowatt hour. So K is called energy meter constant. K को हम क्या बोलते हैं? K को हम बोलते हैं energy meter constant बोलते हैं. Energy meter constant. This is what we call as energy meter constant, revolutions per kilowatt hour. So energy का expression तो आपको पता है, power is equal to energy per time, energy is equal to power into time. So power is equal to VI cos phi into time. So this is kilowatt and this is hour. Okay, chalo. Now let us go for the questions. So try to answer this question. So this, if you see the questions, so this is 690. So try to answer this question. क्या हो गया यार, इसका आंसर बोल बता रहे. So see here, if you see the energy meter is designed to make 100 revolutions, so I can take n as 100 revolutions of disk for 1 unit of energy. Energy is equal to 1 unit. That means 1 unit means 1 kilowatt hour. Okay. Calculate the number of revolutions made by disk when connected to a load current. This I is equal to 50 amperes and the V is equal to 230 volts and cos phi is equal to 0.6. Okay. Time duration is equal to 1 hour. So energy is equal to power is equal to energy per time. Energy is equal to power into time. Power बोलो तो VI cos phi into time. So what is the V? That is 230. Current 50. Cos phi 0.6. So divided by 1000. And the time is equal to 1 hour. So the units are kilowatt hour. So this is energy. He's asking the number of revolutions, na? So from this, what we can write, K is equal to N by E, right? N is equal to K is N by E. That means 100 revolutions per kilowatt hour. 100 revolutions per kilowatt hour. So energy is equal to K is equal to 100 revolutions per kilowatt hour. That means now I want to find out N is equal to K into E. So this is what 100 revolutions per kilowatt hour into this is how much? This is 230 into 50 into 0.6 into 1 divided by 1000 kilowatt hour. So here kilowatt hour gets cancelled. So this 100 gets cancelled. This 10 gets cancelled. Here also get cancelled. 6 5 is 30, 3 is 690. So the answer will be 690. Answer कितना आ रहा है? 690 revolutions. Option A is the right answer. Okay. Chalo, let us go for the next question. Yeah, see this question. What is the answer? So for this question, if energy meter disk makes 30 10 30 10 30 30 revolutions in 200 seconds, so n is equal to 30 revolutions. Okay, and time कितना दिया है? Time is given as 200 seconds. Okay, so when a load of 850 watts, so power is equal to 850 watts is connected to the meter constant. So meter constant is asking, so n is equal to K into E. K is equal to power into time. So K is asking, that is n by power into time. N is equal to 30 revolutions. Okay, so power का Vi cos phi into T. So this is 30 revolutions. So V is equal to how much? Power is already given. Vi cos phi has given 850 watts. And the time is given as 200 seconds. Okay. So now 30 divided by this 850 by 1000. If you do it, it becomes as kilowatt, and 200. This is 60 into 60. If you do it, it becomes hour. Okay. So K is equal to 30 divided by 850 into 200 into 1000 into 60 into 60 revolutions per kilowatt hour. Okay, so these are revolutions per kilowatt. So answer कितना आएगा? This is 30 into 1000 into 60 into 60 divided by 850. So 635 आ रहा है ना? So 636 आ रहा है. So answer is 636 revolutions per kilowatt hour. So answer क्या है? 636 revolutions per kilowatt hour आएगा. Okay. So please answer this question. Nobody is giving the answer. Okay, I will stop here. V is equal to 220 volts. Okay, so this is a single phase power, records a constant load of current 8 amperes for time duration of 5 hours. Power factor is 0.9. The meter disc rotates 2400 revolutions. 2400 revolutions. During this period, what is the meter constant K? So he's asking the revolutions per kilowatt hour. So if you see this, N is equal to K into E. Okay, so K is equal to power into time. So first we have to calculate the power. Power is equal to VI cos phi. So the voltage I am taking as 220. Current I am taking as 8 amperes. Cos phi I am taking as 0.9. So this is the power. Energy is equal to power into time. 220 into 8 into 0.9 divided by 1000, and time is equal to 5 hours, kilowatt hours. Okay, so N is equal to K into E. N is equal to K into E. So K is this. K is given not 2000. N is given, I think. So he's asking K. N is given as 2400 revolutions per kilowatt hour is equal to K into E is this. That is 220 into 8 into 0.9 whole divided by 1000 into 5 kilowatt hour. Sorry, N is equal to 2400 revolutions. Okay, so now K is equal to what? K will be how much? So simplify, correct? Huh? So simplify it. So this gets cancelled. Simplify it. How much you are going to get? कैल्सी यूज करके बताओ कितने लोग लाइव में है, मुझे एक बार रिस्पॉन्स दीजिए भैया. So 220 into 8 into 0.9 into 5 divided by 1000, 7.92 आ रहा है. 2400 divided by answer. So 303 आ रहा है. The answer is coming 303. So 303.03 revolutions per kilowatt hour होगा. So ये होगा हमारा K. Okay. So these are some topics. So अगर आपको कुछ doubts है तो बता दीजिए. And I am giving some notes. That notes is referring to the errors in energy meter. That notes is reference to the errors in energy meter. आप वो errors in energy meter पे आप discuss कर सकते हैं. So you can go through the errors. Why? Because if you see the constructional features of energy meter, the construction features of energy meter will have some problems with respect to phase, with respect to, okay. So that particular topics you can go through as a theory topic. I'm not here to discuss that. Okay. Still, if you have any other doubts from the previous topics, you can ask me. Okay, so we have done recap and we have see the topics. First of all, this is important, 3-phase power measurement by using the 2 wattmeter method. So with the 2 wattmeter method, what are the expressions? This is very are takes a lot of time to understand, but make a notes of this. So from the notes you can get the 4 expressions. So those 4 expressions are typically important. So from this we got the tan phi, and how this 2 wattmeter method is suitable for measuring the 3-phase power, then the relation between the power factor and the wattmeter comments. So from that I have gone for some questions on 2 wattmeter method. So this question you can take as assignment. Please do this question as a homework. Okay, chalo. Now this is one model question, this is another model question. So this is the energy meter. Energy meter में constructional features आप can go through it, and the phase diagram that is important for the IES, not for the gate, and the braking system का fundamental. उसके बाद the basic relation of energy meter, N is equal to KE, so from K is equal to N by E. So we have solved some previous year questions on this, and the errors in energy meter is very, very important. So that part you can go through by self. Okay, that's enough for today. So tomorrow's class I'm going to start the electronic measurements. In the electronic measurements, as many of the students were asking, okay, so they're asking majorly, sir, we need some questions on CRO, so I can discuss those questions here. Okay. This was the lecture number 4, and tomorrow's was the last lecture. So that will be on the electronic measurements. So electronic measurements में CRO आएगा, so इसके ऊपर भी discuss करेंगे. Okay, so I wish you all the best. Thank you. Bye.